first step in initiating a culture is counting the amount of live white blood cells. This can be done using an automated cell counter. The live white blood cell count is used to determine the appropriate sample volume to inoculate into the culture. Some samples have an overproliferation of white blood cells, while others may have a very low concentration. This varies person to person and can change drastically throughout the course of a disease. Not all labs use a cell counter, but it is beneficial to, because if you put in too many live cells, there's a chance that they will consume all the nutrients in the medium before the harvest is performed, and you'll have less mitotic activity. On the other hand, too few cells means you may not end up with enough metaphases to complete the chromosome study. By using a cell counter, you can mitigate these problems and ensure that you're not wasting any precious patient sample. Samples are set up in a laminar flow biosafety cabinet which provides high-efficiency particulate air. This means that filtered air circulates inside the hood to create an invisible but effective barrier, shielding the technologist from the sample and vice versa. Cytogenetics suspension samples are usually inoculated into sterile flasks with a screw top. Before you add your sample to the culture flask, you need to add media. Media is basically food for the cells. There are lots of different types of media, but in general it helps the cells stay alive and encourages cell division. The two main categories are basal media and complete media. Basal media is plain and doesn't have added nutrients. For hem-onc cytogenetics, we use complete media, which is basal media supplemented with L-glutamine, fetal bovine serum, and antibiotics. Typically, we set up 2 cultures for each sample and use 2 different brands of complete media. It's smart to use 2 different types because samples can respond unpredictably, and so one may stimulate a certain sample better than the other. In addition, using different bottles of media reduces the risk of culture contamination. Once you've added your media to the flask, it's time to aliquot your sample. The first step is to mix up your sample and check for any clotting. Clotted samples are treated with collagenase, a liquid enzyme that helps to dissociate cells from a clot and prevent further clotting during the incubation. The volume of sample that you will aliquot is adjusted based on the live white blood cell count you got from your automated cell counter. Samples with high concentrations of white blood cells need smaller volumes of sample added to the flask and vice versa. In addition, stimulated samples receive a slightly smaller volume of sample because they will have more time to proliferate during the extended incubation. If your sample requires a mitotic stimulant, this is the time to add it. Once you've given your flask a swirl, mixing the sample into the media, it is time to put it in the incubator. Incubators are an essential part of how we get cells to divide and proliferate in culture. If you set up 2 culture flasks on one sample, it's a good idea to put them in separate incubators to reduce the chance of culture failure due to contamination within the incubator or in the chance that an incubator stops working. Incubators are designed in part to imitate the conditions within the body so that the cells stay alive and continue dividing. Inside an incubator, the temperature is set to 37 degrees Celsius, CO2 tanks provide a 5% CO2 concentration, and a water pan helps maintain a high level of humidity close to saturation. These factors, among others, help the culture stay within a pH range of 7.2 to 7.4.